In this fourth video of the series, we examine the consensus model used for blockchain. In particular, we use the simplified version of the Bitcoin or Nakamoto consensus as example. We will state the definition for distributed consensus. This old problem in computer science we look at in more detail. Now Bitcoin and its blockchain seem to have solved this problem. We will examine the steps in the Nakamoto consensus model, and we will define the concept of consensus chain. As this model has some drawbacks, new models have been and continue to be proposed. A distributed consensus protocol is needed for a distributed network. There is no central authority, so agreements need to be reached amongst the nodes. Let's say we have a number of nodes, n, each with their own value of the item we want to reach agreement on. There are some malfunctioning or malicious nodes. We do not know which those are. A distributed consensus model has two central properties. First, the protocol needs to come to an end. It needs to terminate. Upon termination, the honest nodes need to agree on a specific value for the item in need of agreement. Secondly, the agreed upon value needs to be one that was originally proposed by an honest node. As stated, this is not a new problem. Usually this is only taking into account malfunctioning or failing of nodes, and it is solved in such a way that the nodes that communicate successfully, that have quorum, can set the agreed upon value. Quorum is mostly defined as half of all plus one. This means that the set of nodes that can communicate that do not reach quorum either stop functioning or at the very least do not mutate any values. Even these mechanisms are not stable in some specific situations and leads to complicated setups. As an example, we briefly look at the distributed database. We look at two data centers, half of the database nodes in each. So we have DCA with two nodes. And we have data center B with two nodes. And these data centers can communicate with each other over a network. Now if A fails, B does not have quorum. Quorum in this case is half of 4 plus 1, which is 3, and B only has two nodes. That means that B also stops working voluntarily. So in this case we need a tiebreaker or voting node somewhere else, with network connections to A and B. Let's call this C, and it has one node. And we have network connections to B and to A. The quorum now remains at half of 5 plus 1 equals 3, with some rounding. Now if A fails, B can still talk to side C. Together they are 3 nodes. This is quorum, so B can keep functioning as a database. As C needs to be in a different location as A and B, this can be a costly solution. And still situations can be created where even this setup fails. Now Bitcoin seems to have solved the distributed consensus challenge. It works and has worked for more than 7 years now. This is one of the reasons that sparked a lot of interest in blockchains apart from the cryptocurrency enthusiasts. However, the consensus model has been empirically proven. There is no mathematical proof yet. This specific model is called Nakamoto consensus, after Satoshi Nakamoto, the inventor of the Bitcoin protocol. One important detail to note already is that this consensus is not instantaneous, which would be needed for the database or file system. Let us examine the steps in the Nakamoto consensus model. 1. All nodes broadcast transactions they learn about to their neighbors. 2. Each node collects new transactions into a block. 3. In each round, which is essentially every 10 minutes, one random node gets to propose its new block as the next block in the chain and broadcast this to the network. 4. Other nodes check the block against the rules in their copy of the current blockchain and transaction set. For example, are all coins in the transactions in the block unspent, and are all signatures valid? Nodes will then express that they accept the proposed block by starting to build a new block containing the hash of the block proposed in step 3. Now the cycle runs again from steps 1 and 2. And this is almost the complete consensus. However, we need an extra rule, because the consensus, the process of the previous slide, can lead to diverging separate chains due to timing in the network. The eventual longest chain of blocks is called the consensus chain. This is the chain that forms the history and the ledger. The block or chain of blocks that are not part of the consensus chain do not exist. In this case, this setup is the consensus chain. Why this can happen has to do with how step 3 on the previous slide is implemented in reality, which can lead to multiple nodes proposing a block at more or less the same time. We will go into this in detail in future lectures. This is not the only model. A whole new field of study around consensus has started a couple of years ago. Many other models have already been proposed, and we will look at some of those in future lectures. This concludes this video. I hope you enjoyed it. The next video will go into hashing. For questions or suggestions, please contact me on the email address shown. Thank you.